It can be helpful to see graphical representations of the rate law and integrated rate law solutions for different orders of reaction. We'll start with the rate laws first, and we'll see three graphs representing the zeroth, first, and second order reactions. If we look at the rate law for these different reactions, we can see that rate equals K for the zeroth reaction, K times concentration for the first order, and K times the concentration squared for the second order. And if we look at plots of rate versus time, what we can see is that rate is a constant for the zeroth order reaction, and that means that the rate will not change over time. Rate remains constant. For the first order reaction, rate is equal to K times the concentration, and concentration is going to change over time. As time goes by, the reaction will use up some of the reactants, so the concentration of those reactants go down, which means the rate also has to go down. So the rate would decrease over time. For second order reaction, rate is equal to K times the concentration squared, and that means that as the reaction proceeds, the concentration gets used up, and as concentration is used up, it has an exponential effect on the rate. For these different orders of reaction, we can also look at the graphs for concentration versus time. And one way to look at concentration is by using an integrated rate law. If we look at the solutions for the integrated rate law, where we solve for A at some time t, for the zeroth order reaction, we find that it is equal to minus kt plus the concentration at time 0. For simplicity's sake, where we're only looking at time as our x-axis, the x-axis variable is t, so we can say that effectively the concentration of A is minus t, just to make things easier. For first order reaction, you can solve for A and you find, and again, we can simplify this. This is effectively e to the minus t. For a second order reaction, we can again solve for A. These simplifications are not designed to let you do any calculations. They're just to let us more easily see what the shape of the graph should be. So for concentration versus time for a zeroth order reaction, initially you would have some concentration and it would decrease with time linearly. First order reaction will again start at some initial concentration and it will decrease according to e to the minus t. For a second order reaction, the concentration will decrease as 1 over t.